Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on the force exerted by the jet on the curved plate when the plate is moving in the direction of jet. So, similar concept we have derived an equation in our last video lecture. So, based on that concept, we'll solve this problem. So, we've identified what is the force exerted by the jet on the plate, and also we have calculated what is the work done by the jet. So based on that, we'll solve this. So here I have taken a question: a jet of water of diameter. This is the jet of water of diameter. We can see it is given 7.5 centimeters. Strikes the curved plate at its center. So this is the conditions. Condition of the plate. What is the types of plate and what is the condition? With a velocity of 20 meter per second. The curved plate is moving with a velocity 8 meter per second in the direction of jet. The jet is deflected. The jet is deflected through an angle of 165 degree. By assuming that the plate is smooth, we need to assume this condition: the plate is smooth. Find the force exerted on the plate in the direction of jet, power of the jet, and the efficiency of the jet. So these are the 3 points we need to calculate. So before going to solve this one, let me just draw a simple diagram for this. Actually, the plate was like curve condition, and the impact of jet on this plate is in the center. You can see at the center, the plate is curve plate. You can see this is a curve plate is there, and the plate is in moving condition. This plate is moving condition. After striking this one, the plate started moving with a velocity of small u, and this is the impact of jets. So this is the impact of jets is nothing but v, and what is the v is given? So v is given here 20 meter per second, and u is given equal to, here it is, u is given 8 meter per second. Okay, and this impact of jet will be like, the jet will be in the diametrically, like it will move with a circularly. So here the diameter of this jet, this diameter of this jet is given 7.5 centimeter. Okay, and yeah, the jet is deflected through an angle 165 degree. So if you see, when the jet is coming out from this plate, we need to consider the plate is smooth, so that what is the velocity is coming from here, the same velocity will be goes out from this plate. When we consider the plate is smooth, there is no loss of energy because of the smoothness of this plate. So what is the velocity is striking this plate, the same velocity will be come out from here. So when the velocity of jet is striking to this plate, we need to consider that is relative velocity. That means the v minus u. So the same v minus will be come out from here. Okay, so this jet, see, the jet is deflected with an angle. So deflection means, the deflection angle we need to consider, actually deflection angle means this one. Okay, the opposite angle of this jet and the plate. So angle between this jet and the plate is nothing but theta, and the deflection angle is nothing but this is 180 minus theta. So here the deflection angle given 165. So let's find out. Let's go for the solution directly. So data given mostly I have written here. So first I'll write one more thing. Diameter is given 7.5 centimeter. So this one we can convert into meter. So it will be like 0.075 meter. So from here we can identify the area of this jet. This is nothing but pi by 4 d square. So you can calculate the area. Now similarly, velocity of this jet is given. This is 20 meter per second, and small u is given 8 meter per second. And now angle of deflection is given 165 degree. So here let's write down, this is angle of deflection. Angle of deflection is given 165 degree. So we can find out now the angle between the relative velocity, the absolute velocity v absolute, and velocity of the plate, outlet of the plate, plate outlet, that is nothing but theta. So this is actually 180 minus 165. So this is 15 degree. So this angle is, theta angle is nowadays 15 degree. Okay. And here we can calculate the value of area. This is pi by 4d square. So pi into 0.075 square equal to this divided by 4. So this is 0.004417. So this one you can write, this is 0.004417. This is a meter square. So now we need to find out first point. The first point is given, the force exerted. The first point is given, the force exerted by the jet on the plate in the direction of jet. So this is nothing but, I'll write force, write shortcut here. This is force exerted by the jet on the plate in the direction of jet. So that is, I'll write, this is Fx. So this formula actually, this formula only we have derived in our last video lecture. So that is nothing but Fx equal to, this is rho A, and here it is V minus U square, and this is bracket 1 plus cos theta. 1 plus cos theta. This is the formula. Now we need to just put the value here. This is Fx, and here rho is nothing but density of the water. Here you can see the water is there, and this is area already 0.004417 into, this is 20 minus 8 square, and bracket start 1 plus cos, this is 15 degree. Okay, so this one we need to find out now. Now as per this, I'll go for directly multiply 1000, multiply this one, 20 minus 8 square, that is 12 square means 144, multiply, bracket start, this is 1 plus, here I'll write 15, and cos 15, yeah, this equal to be how much? This is 1250.667. So I'll write, this is 1250.6, I'll write only 1250.6. So final answer we got here, this is 1250.6 Newton. This is the first answer what we have got. Now the second one we need to calculate. The second one is nothing but the power of the jet. So before going to calculate the power, we need to find out the work done actually. So now we'll write work done by the jet. Work done by the jet on the plate per second. On the plate per second. So I'll write directly here, it is Fx into small u. So Fx into small u is nothing but, Fx already we got here. This is 1250.6 into u is 8. So this is 1250 into 8. This is 9600. This is 400. This is 10,000. 10,000. Here I'll write, this is 4.4048. So this much Newton meter per second. This is our work done actually, not the power. Let's see, multiply 8, 10,005, or 4.8 in the sense 4 will come this side, that will be 5. So here 10,005.34. So here also I'll write, this is 10,005.34 means this is 4 only. Okay, yeah. So this is about the work done. The next is we need to find out the power. So we need to, as I told you, we need to calculate the power of the jet. Power of the jet. So power of the jet is nothing but, you can write, this is work done by 1000. So what work done by the jet per second actually, this one. So work done by 1000. So what we got here, 10,005.4 divided by 1000. So we'll get here how much? Near about 10 kilowatt. This is second answer. And our third answer is we need to find out the efficiency. So third question, To find out this efficiency, again we need to calculate two things. One is output, another one is input. So let me write here. This is the third point. Yeah, efficiency equal to output by input. So output is nothing but what is the work done by the jet. Work done by the jet per second. And what is the input? Input is nothing but also same thing. We need to find out the kinetic energy of jet. Kinetic energy of jet per second. So this is the jet of fluid which is moving. This is our inlet condition. So that is nothing but kinetic energy. So output of already we have found. So this is nothing but 10,000 5.4 and divided by half mv square, this one. So this one half mv square. This one I can again write in the place of m, I can write half rho a v. So this one we can write half rho a v q. Okay, so just you write this value 10,005.4 and this is divided by 1 by 2 into rho. This is 1000 into a 0.004417 into the velocity. This is v, nothing but 20 q. So we need to find out this. Now, yeah, this one I'll do divided by bracket start and I'll do 0.5 multiply. This is 1000 multiply 0.004417 into 20, 20 and 20. This is bracket close. Yeah, 0.566. So we got the answer here. This is our efficiency. 0.566 is nothing but efficiency equal to, we got here 56.6%. This is the efficiency of the jet, and this is the power of the jet, and this is the force exerted by the jet on the plate. I hope you understand this problem, how to solve it. Only thing is that we need to remember this first formula, so remaining things can be done easily. I hope you understand this problem. Still, if you are having any kind of doubt in this, you can give a comment on the comment box. Thank you all.